Okay, so this is the problem we're solving. Show that g1 equals y4 plus y2 plus y, and g2, which is x squared plus y squared plus 1, is a standard basis in the polynomial with rational coefficients with respect to lexicographical order with x greater than y, and decide whether or not f1 being that or f2 being that is in the group generated by g1, g2. Now we just start with this part of the problem, and then we'll move on to what's after the end. So when you see standard basis, you need to find the S-polynomial. This is the formula to find the S-polynomial. So this means that S-polynomial is the lowest common multiple of the leading monomial of g1 and the leading monomial of g2. So we'll find that first of all. I'll do that in a minute. I'll just go through this. So LCM over the leading monomial of g1 multiplied by g1 altogether, minus the leading coefficient of g1 over the leading coefficient of g2 multiplied by the LCM again over the leading monomial of g2 multiplied by all of g2. So first of all, we'll find out the LCM, the leading common or the lowest common multiple. So that's just a short term for the leading common multiple of g1, or of the leading monomial of g1 and the leading monomial of g2. So the leading monomial of g1 is y4, or y to the power of 4, because, as it says, it's lexicographical order with x greater than y. As you can see, g1 is already in lexicographical order, meaning that you look at all the x's first, and there's clearly no x's there, so then you move on to the y's, and y to the power of 4 is greater than 2 is greater than 1. So y to the 4 is the leading monomial of g1. When we look at g2, it's also already in lexicographical order with x greater than y, because we look at the x's first, and x squared is the only one that contains any x, so that's the leading monomial. Then neither of the other two have x's, so then you look at the y's, and y2 is greater than just 1. So the leading monomial of g2 is x squared. So the least common multiple of the two of these, obviously they have nothing in common, so the leading common multiple is just simply the two multiplied together, x2, y4. So then we fill in to our formula again to find the S-polynomial. So S g1 g2 equals leading common multiple, which is x squared y to the 4, over the leading monomial of g1, which is y to the power of 4, multiplied by all of g1, so we'll put that in brackets, y to the 4 plus y squared plus y, minus the leading coefficient. So the leading coefficient of g1 is simply 1, because the leading monomial, leading term, is y to the power of 4, and there's no number in front of it, which you assume is just 1, over the same with g2 is 1. So it doesn't really matter in this case, but in other cases it would if the number was a 2 or a 3 or anything else. Then you multiply it again by the leading common multiple. Now, I hope that the fact that my camera ran out of battery doesn't affect this video and I don't have to put 2 up online, but anyway, where was I? Yes, so we have this formula nearly filled in. All we need to do is put the LCM over the leading monomial of g2, which is x squared, and multiplied by all of g2, x squared plus y squared plus 1. and we just figure it out then. Just cancel off anything you see. Y to the power 4 over y to the power 4 cancels out. So just multiply x squared. Keep it in lexicographical order if possible. I might do that a bit in a minute, but just complete what you see. X squared y to the 2 plus x squared y. It's important to put this in brackets just in case you make a mistake and only multiply x squared by the first term. You have to multiply it by the whole of g1. So then your minus 1 over 1 is just 1, so you can ignore that. X squared and x squared just cancel out. Minus x squared y to the 4. Keep the minus in, don't forget the minus. Minus y to the 6 and minus y to the 4. So those two terms cancel out, and I'll just rewrite this S-polynomial in lexicographical order. X squared y squared actually already is in lexicographical order, which is handy. X squared y minus y to the power 6 and minus y to the power of 4. Now, that's the S-polynomial we've got. Now we need to find out, using the S-polynomial, if G1, G2 is a standard basis in this field. So all you do is put down your S-polynomial. Again, you don't have to, but I just want to put it over to the side of the page to make more room for myself. And in much the same way as we do Euclid's algorithm, in a similar way, we're going to take away either G1 or G2 and multiples of either G1 or G2, and if we end up with 0, then we know it's a standard basis. Now, we already know it's a standard basis because the question says show. Sorry, I'm after going down the page there. Show if it is one or not. So that means you can assume it is. All you need to do is show it. So if you end up proving that it's not, you know you've gone wrong somewhere. It's different for the second part of the question where it says decide whether or not. So we don't know whether or not it is. We have to decide that by proving it. So up we are here. You leave a blank minus, leave a blank for multiples, and then you'd have to decide whether G1 or G2 is more appropriate to take away from the S-polynomial. And you do that by looking at the leading terms again. As you can see, it's x squared y. No multiple of y to the power 4, which is the leading term of G1, could cancel out the leading term of the S-polynomial. However, there is a multiple of x squared that could cancel out x squared y, which is y multiplied by x squared. So that's why we choose G2. X squared plus y squared plus 1. It's only the leading term that really affects your decision. So obviously y multiplied by x squared, we'll put that over here, is x squared y. You also have to multiply the rest of the terms. Y by y squared is y to the power of 3. So I'll put that down at the end over here because we're trying to keep it in lexicographical order at all time. And y multiplied by 1 is y. Because you're taken away, you have to change the signs and cancel it out. And keeping it in lexicographical order, x squared y minus y to the power 6 minus y to the power 4 minus y to the power 3 minus y. Again, look at the leading term, x squared y. Okay, I'm after making a mistake, sorry. That should have been x squared y squared. Y squared. Yikes. Sorry about this. It's just a matter of changing to y squared. This to y to the power of 4. This to y squared. So then minus y4 is minus 2 to the power of y4. There's no y to the 3, and minus y squared. Sorry about that, I made a mistake, I just forgot to put a y squared in here. So then x squared multiplied by y will cancel out this, so x squared y, y to the power 3, y to the power 3 plus y, change the signs, cancels out, minus y to the power 6, minus 2 y to the power 4, minus y to the power 3, minus y squared, minus y. And you might be thinking, you know, this is actually expanding, and I'm not really whittling it down, but, you know, just keep at it. It can be a bit daunting at times, but just keep going until it starts to whittle down, starts to cancel out. So now, y to the 6 minus y to the 6 is the leading term, so x squared won't cancel it out. No multiple of x squared can cancel that out, so we have to move on to g1, and we'll just stay on the same line, leave a blank for multiples, and then put down y to the power 4 plus y squared plus y, and obviously y minus y squared would be the term that minus y squared by y to the power 4 would be minus y to the power 6. Also multiply the rest of the terms. Change the signs, just change them to multiplices. Cancel out. Would be minus y to the 4. That would also cancel out. And minus y squared minus y. Again, it's y to the 4 multiplied by what would be minus y to the 4 would be minus 1. Minus y to the 4 minus y squared minus y. Things are looking good. Change the signs. What have we got? 0. So therefore G1, G2 is a standard basis. That field. So that's the first part done. Now we need to move on to the and decide part. Sorry if I'm moving out of sight of the camera. I keep forgetting about the camera. So now we'll go move back to the question and see. That's what F1 is. You have to decide whether or not F1 or F2 is in the group generated by G1, G2. So we'll start off with F1 and do that first of all. So F1 is x to the power 4 minus x squared with y. So this is already in lexicographical order as well. Minus 2y squared. So it's not good to decide what order you're staying in and stay in it the whole time at all costs. And right, you're basically doing the same thing as we did in the last step. So you're just leaving a blank, and then you have to decide, you know, is it in the group generated by G1? Well, we find out. We find out if we can take away multiples of G1 and G2, and if it equals 0, then yeah, it's in the group generated by G1 and G2. So leading term here is x to the power 4. So again, we're going to be using G2 because that has x's in it. By G2, so G2 is x squared, what is it again, plus y squared plus 1, plus y squared plus 1, and so x squared multiplied by x squared plus x squared y squared, I should say. Not making that mistake again. And plus x squared. Change the signs. It's got a bit cramped up here. Spread them out a bit. Leading monomials cancel out. Minus x squared y squared. This might take a bit longer than the first step, and I might have to change pages, but that'll be okay. Minus x squared y minus x squared plus y to the power 6 minus 2y squared minus y minus 1. And then you look again, and yeah, g2 is still okay, so we'll multiply g2 by minus y squared minus x squared y squared minus y to the power 4 minus y squared. Change signs. Minus x squared y minus x squared plus y to the power 6 plus y to the power 4 minus y squared minus y minus 1. And yep, g2 is still okay, so we multiply by minus y. You just keep going. Might seem like you're going around in circles here, but as I say, it'll eventually dwindle down. Plus y to the power 3 minus y plus minus plus cancels out, minus x squared plus y to the power 6 plus y to the power 4 minus y cubed minus y squared. That cancels out, and minus 1. And yeah, we can still stay on this, and it's just minus 1, this last multiple. Minus x squared minus y. Ooh, I should put this down here. Minus y squared minus 1. Change the signs. And luckily a few things are cancelling out here. So we end up with y to the power 6 plus y to the power 4 minus y to the power 3. So obviously x squared is no good to us anymore. So I'm just going to... Hopefully you can all see this. Sorry if I'm going a bit fast, or if I'm talking while I'm down the bottom of the page. And anyway, move on to another page. Restation it up here. Y to the power 6 is what was our last remainder. Y to the power 6 plus y to the power 4 minus y to the power 3. And then we'll just do the same thing. Leave a little space for multiples. Multiply by our g1 this time, which is y to the power of 4 plus y squared plus y. And multiply by y squared, y to the power 6 plus y to the power 4 Sorry about this, I'm after making another mistake. Sorry. Now, when I was here, I multiplied y squared by minus y, and I got plus y to the power 3. That should have been minus, so that should be a plus. So down here, this should be a plus. And again, this should be a plus y to the power 3. Come back up here and just change that to a plus. Simple mistake to make, but we all make them. And y squared by y is plus y3 and y to the power 3. Change the signs, and that will be equal to 0. So that means that f1 is an element of the group generated by G1 and G2. Now, because I might have been talking while you couldn't see what I was writing, I'm going to do the second part as well with F2. It's much the same thing, but it's just doing the same thing again, and you'll be asked these type of questions in exams and whatnot. So again, F2 is, you can see me, F2 is x to the power of 4 minus x squared y plus x squared plus y to the power of 6 minus y squared minus y. Now, seems long-winded. Who knows if it's even going to be in the group, but you know, you have to keep going until you can prove whether or not it's in. So again, we start with G2 minus a space multiplied by G2, which is x squared plus y squared plus 1. Multiplied by x squared by x squared is x to the power of 4, x squared plus y squared, or x squared by y squared is x squared y squared, plus x squared y squared, x squared plus 1 is x squared, plus x squared. Change the signs. Minus, minus, minus. Cancel those out. Minus x squared y squared, minus x squared y. Go straight down from there. These two cancelled out. Plus y to the power 6 minus y squared minus y. Then, yeah, G2 still works. Multiplied by minus y squared. For a minute there I thought I was doing the same one at F2 and F1, but they're similar, F1 and F2. Yeah, so minus y squared by x squared is x squared. Sorry, minus x squared y squared minus y squared by y squared is minus y to the power of 4. Put that here, minus y to the power of 4 minus, and that's minus y squared. Change the signs, plus, 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 cancels out, minus x squared y plus y to the power of 6 plus y to the power of 4. These two cancel out, and then minus y. And yep, we're still good. Put in minus y, minus x squared y, minus y to the power of 3, minus y. Change the signs. To the power of 6 plus y to the power of 4 plus y to the power of 3, and they cancel out. And now we need to move on to G1. Leave space for multiples and put in G1. And it's looking good, isn't it? Where is it? Y to the power of 4 plus y to the power of 2 plus y to the power of 1. Or just y. And multiply that, y squared. Y to the power of 6 plus y to the power of 4 plus y to the power of 3. And you've got 0, so that means that 2 is also an element of G1, G2, and that worked out faster because more things cancelled out as we went along. So that's the question answered. Sorry about that, any mistakes I made. This is my first video. Thank you for watching.